Okay, so we're still in 8.4. And we still have established the identity as our instructions. And we're going to look at 29 next. So for 29, we have secant theta minus 1 times secant theta plus 1, and we want to show that that's the exact same thing as tangent squared theta. Okay, that's a good question. Let's pick a side. Which side do you want to work with? Probably the left, right? Because it looks like you've got a little more. So yeah, I would start with the left-hand side. You can FOIL it out, or if you see the rule right away, that's a plus or a minus b times what? A plus b, which is a squared minus b squared. But you'll get the same thing if you FOIL it. Is everybody okay? Now, the minute you see squares like that, I'm always like thinking of my Pythagorean identities, those three, because they have squares in them. And so I know there's a relationship between secant and tangent. I want to go back and remind myself. I think it's tangent squared theta plus 1 is what? Secant squared theta. And you just have to know that. But look, if you subtract the 1, sure enough, what do you get? Tangent squared theta is what? Secant squared theta minus 1. And so then you can say, well, this is tangent squared. That's it. Okay, I think I've got 3 more to show you, and I can't even remember why I picked all these, but I guess we're going to find out. So, no time like right now to figure out why I picked them. All right, let's take a look at question 51 next. So again, establish the identity. Let me try to make this look better. There we go. Okay, and 51 is the next one. We have 1 minus the sine of v over cosine v. And then plus, we have cosine v over 1 minus sine of v. Oops. And then they want us to show that that's really just 2 secant v. All right, so again, we want to pick the side that we have more to work with. We keep picking the left, but the left side definitely has more. So I'm going to start on the left. And because I'm trying to get to the right, and the right is only 1 term, I'm thinking, well, let's get a common denominator and at least go from 2 terms down to 1. Do you guys kind of see it? So that's where what my brain is thinking. So we need to get a common denominator, which would be cosine v times what? 1 minus sine v. That'll at least get us down to 1 term. And looking at this one, I'm like, all right, this one needs the 1 minus what? Sine v. And this one needs the cosine v. Do you guys see it? So we're going to write that out. We know then on the left, we've got 1 minus sine v times what? 1 minus sine v, correct? And then over here, we'd have cosine squared v, because you've got cosine v times cosine v.
Can you write that first 2 terms cosine squared?
You can. The only reason, and I'll tell you guys this, that I didn't write it as 1 minus sine v squared is because then you have to remember the formula. And I'm not sure you guys will remember how to do that. If you do, that's great. If not, you would wind up unsquaring them and foiling it anyway. So I left it in the FOIL format. But it depends, you know, if you remember these formulas, I'll go ahead and give them to you. If you remember them, write it as a square. But I'm going to put or FOIL it. And if you want to FOIL it, you want to leave it in that form. You guys okay? And then you don't have to memorize the formulas if you've forgotten them. Even when I teach that and I don't remember what course that is, but I think it's 1033. I'll tell them you can memorize the formulas or not. It's kind of up to you. Sometimes you need it for factoring purposes. I won't lie about that, but you know. Okay, so what we need to do now is we're still trying to get, don't forget in the back of your mind, you're thinking, I want 2 secant V. That's what I'm trying to get at. I'm going to go ahead and FOIL it out, or you can use that formula that I showed you above. You can use the A minus B quantity squared. But if I FOIL it, we would do 1 times 1 is 1. 1 times negative sine V is what? Negative sine V. Negative sine V times 1 is what? Negative sine V. And then negative sine V times negative sine V is sine what? Squared V. And most of you guys remember how to FOIL, so. And then we're still left with what? Cosine squared V. And then, like I said, just leave that factor down there. Let's see what kind of happens. I don't want to distribute it yet. I just kind of want to see what I get. Couple of things. Do you guys see these are like terms right here? Negative sine V becomes negative what? 2 sine V. And then I'm looking at this. Why am I kind of looking at that? It equals 1. Does everybody see it? Sine squared V plus cosine squared V equals 1. So I'm going to change that whole thing to 1. And then this one plus that one becomes what? 2. And I'm thinking, okay, what did we want again? We want 2 secant V. Okay. All right, we're getting there. In the numerator, do you guys see there's a common 2 that you can factor out? So take out your common 2. And now do you guys see everything's factors? You've got multiplication in the top, multiplication in the bottom, which means you can cancel. How are you doing? Which leaves you with 2 over what? Cosine V, and sure enough, what is that? 2 secant V, and that's what we wanted. Two hard sections back to back, right? Because the inverse stuff is a lot, and this is a lot. I will tell you, it does get better, so try to hang in there. Like some of the chapters get much, much better. I think the second test is kind of the worst of it. It is. It's a rough test. It's the hardest test. Okay, you guys all right? All right. Okay. All right, I just want to keep showing them to you, you know, so that I can show you different cases. Let's look at, we've got 2 more we're going to look at. Let me grab the instructions here. And well, that was 51, right? Yeah, so let's look at question 55. Now, this one, I honestly think you could probably go either way. You could start with the left side, which is actually what I did, or you could start with the right side. And they both look like they have quite a bit, because on the right side you'd FOIL that out and kind of go from there, and then on the left you're probably going to wind up having to use conjugate. I think that's why I picked the left, is because I wanted you to see conjugate. But I think in this case you could probably do it either way. So when you get home today, I'll do the left with you. But go home maybe and try going from the right to the left. That's good practice for you, and then you can see it, because you're basically working backward from the way I'm going to show. So the only reason I'm picking the left is just to show you the conjugate kind of in action, but I think you could easily go either way. So we'll start with the right. And the whole reason I wanted to show you this one is my idea was to use conjugate. Now, why would I think to use conjugate? Let me explain my thought process so you guys understand where I'm coming from. I know on the right I don't have a denominator. Do you guys see that? And so my goal is to kind of get rid of those two terms down there. I'm like, well, if I can get it down to a single term, I have a better chance of canceling it. And so that's why I'm thinking of using conjugate here, is because I can get it into difference of squares and then kind of go from there. So I'm going to do 1 minus sine theta times 1 minus sine theta, and I'll let you guys see kind of how it works out. So I'm definitely using conjugate here. The reason I applied it to the denominator was to hopefully ultimately get rid of that denominator being two terms. Okay, so up at the top, I've got 1 minus sine theta times 1 minus sine theta. I'm not sure if I want to write that as a quantity squared yet or not, so I'm just going to leave it. But in the bottom, I definitely want to use the conjugate part, which is the a plus b times what? A minus b we know is a squared minus b squared. That's why I brought it in. So I'm going to have 1 squared minus sine squared. Are you guys okay with that? So you're left with 1 minus sine theta times 1 minus sine theta. And then down here, we've got 1 minus sine squared theta. Too bad it's just not 1 minus sine theta. We just cancel it, but it's not. Okay, so now what I'm thinking is, I'm like, well, okay, I don't know how much better I made this for myself, but I know I have an identity, right? And the identity says sine squared theta plus what? Cosine squared theta is 1. That means that cosine squared theta would be what? 1 minus sine squared. And that's how the conjugate is going to get me down from two terms in the denominator to 1, because I'm going to replace 1 minus sine squared with what? Cosine squared. And I'm going to take a quick peek at the other side. Okay, I've got a ways to go. So I made a tiny bit of headway. I haven't made much. All right, because I'm trying to ultimately get over it, looks like, because I'm looking at this side, I'm going, okay, I need secants and tangents. So I need to kind of FOIL out that top part. I need to multiply it out and then kind of start splitting it up to kind of get over to that. So what I'm going to do, let's FOIL this part. We'll do 1 times 1, then 1 times negative sine theta is negative sine theta. Here we get negative sine theta, and here we'll get plus what? Sine squared theta. Make sure you see the FOIL there. And then down here I have cosine squared v. Everybody all right? Okay, notice these are like, so they become what? Minus 2 sine theta. And I'm actually going to take the original identity so I can concentrate on what I want here. I'm going to move it over to a new screen, so I'm like, this is where I'm trying to go. And I'm going to move this over and show you how we're going to get there. We basically have it, but I need to show you how. Okay. All right, I'm going to move this over. Are you guys with me to that step? Everybody sees it? Okay, in order to get that secant theta minus tangent theta quantity squared, you're going to want to break. This is another trick that I actually haven't shown you yet. you can always take, I don't know how much you remember from your algebra, but do you remember if you have a common denominator like that, like we do here, you can split it up. It's the same thing, right? Okay, so I'm going to write this as 1 over cosine squared theta minus 2 sine theta over cosine squared theta plus sine squared theta over cosine squared theta. So I'm basically using that rule. I'm splitting your terms in your numerator up over that common denominator, okay? Okay, there's still a little manipulating. This is really 1 over cosine theta quantity what? Squared, because 1 squared is 1, correct? This is minus 2 sine theta, and then cosine squared is really 1 over cosine times what? 1 over cosine. Do you guys agree? Because cosine times cosine is cosine what? Squared. And then this is really sine over what? Cosine squared. Are you following me? Because the square goes to both the top and the bottom. This is kind of a nasty one. There's a lot to it. Yeah, this one's, I'm like, ugh, we're still not done. Okay, now let me show you again. I want to keep this where we're trying to go in my face so I can kind of, I know it sounds silly, but I need to see where I'm trying to go. I think we have it here, but I'm going to clean it up for you so you can see it. All right, look. 1 over cosine is really what? Secant. But then you've got the square. So do you guys see that this is secant squared theta? Sine over cosine is really what? Tangent. So that's minus 2 tan theta. And 1 over cosine is really what? Secant. How are you doing? Yep, and then that's tangent squared. See if you see all that. Are you following me? Now, sometimes it's easier to kind of come back here real quickly. One of my professors used to always say, go behind the curtain and make sure what you've got is correct. So if you kind of go behind the curtain, this is what you want. Right? Let's see if that's what we really have. Because if you take secant theta minus tangent theta, there's 2 of them, right? And you FOIL that, we should get this. Let's make sure that we do, all right? So we're kind of behind the curtain checking it, making sure we've got it. Secant times secant would be what? Secant squared. Do you see it? Secant times negative tangent would be what? Negative secant theta what? Tan theta. This would be negative what? Tan theta secant theta. Let me make a little room. And then this one times this one would be plus what? Tangent squared. Does everybody see that? So you've got secant squared theta. Now, are these 2 the same? Yeah, because 5 times 2, 2 times 5, same thing. So you have minus 2 what? It doesn't matter. Secant theta, tan theta, or tan theta, secant theta, however you want to write it. Do you guys see? And so is that what we have? Yes, it is. Okay. So then you can say, yes, this is secant theta minus what? Tan theta squared, which is the right-hand side. But see how they kind of start getting more and more difficult and involved, and you can see how you can get off the track with them. You can just, I've done it, and I see these all the time, and I've had them stump me before, like, I don't know, and then it'll just suddenly hit me, oh, this is what you have to do, but they're hard, so, you know. We like it better when we have a step system that works every time, and that's not how these work. Okay, I'm going to show you one more. I think this is all we're going to be able to do today. So let me show you one more of the identities. I can't remember if this one's not too hard, I'll briefly start the next section. If this one's really hard, it's going to take us the rest of the class period to finish it. But let's see. So establish the identity. Go all the way back. And I actually think this one's going to be easy. So you never know in the book. Just because it's lower down in the problems doesn't mean it's necessarily harder. So this is question 71. Yeah, this is not going to be hard. So secant theta minus cosecant theta over, I can't write today, secant theta, cosecant theta. And they want us to show that that's the same thing as sine minus cosine. I don't know, this looks like you could go either way here. I think it's about equal difficulty, to be honest with you. Starting left side, right side doesn't matter. You want to do the right side? Okay, let's do the right side just for something different. I did it the other way and it was not bad, but I actually think the right side might be just a hair easier. Okay, so let's start on the right side just to play around with it. And then if you look at my old video, I think I did the left side. So, okay, so if you start with the right side, tell me what you're thinking to get the left side. Sines and cosines you don't want. You don't want sine and cosine. You want to get over to secants and what? Cosecant. So sine is really 1 over what? Cosecant, isn't it? And then cosine is really 1 over what? Secant. So at least you have the right trig functions in there now. Are you guys all right? Now look, how many terms do you currently have? You have 2. But to the left side, which is what you're trying to get, you don't have 2 terms, you only have 1. So get a common denominator. So we're going to write it with a common denominator of cosecant. Wait, I'll do it in the same order as what we have. Secant theta, cosecant theta. And let's see, this one's going to need the secant, right? And this one's going to need the cosecant. Do you guys see it? And so this will give me secant theta, and this will give me what? Cosecant. And you got it. I think that was easier, actually. I did the other way, and I converted the secant, the cosecants to sine and cosine, but it was a little more involved that way. So that was definitely the better way to go. So, how's that? You guys got it? Everybody got it? Okay. The good news is we're done with this section. So, all right, I do have time to just briefly start the next section. So I'm going to go ahead and stop and restart here.